Problem 20. A scientist walking through a forest recorded as integers, very important, the height of 5 trees standing in a row. She observed that each tree was either twice as tall or half as tall as the one to its right. Unfortunately, some of her data was lost, and basically we're trying to reconstruct her data. And the average height is given to us to be something 0.2. So what was the average height? We're trying to find what this blank is. So let's say that this blank was y. This number is y.2. Well, how do we find the average in the first place? Well, the average, right, is t1 plus t2 plus t3 plus t4 plus t5 divided by 5, right? It's the sum of the heights divided by the total number of trees gives you the average height, which is y.2. So if we were to do this together, right, this would become times 5. In other words, this would be 5y plus 1. Right? Because whatever y is, we multiply this by 5, so that's 0, we carry the 1, 5 times y is 5y, and then we add the 1. So it's 5y plus 1.0. So in other words, the number is just 5 times y plus 1, whatever y might be. So the sum of the heights must satisfy this expression. Therefore, we have a guiding light to guide us into what these terms might be. We already know what t2 is. t2 is 11. So what is t3? Well, t3, right? Well, every tree is either twice or half as tall as the one on its right. So 11 must be equal to 2 times t3, or 11 must be equal to half times t3. So t3 can either equal 22, or t3 can either equal 11 over 2. But they must be integers. So t3 must be equal to 22. So this has to be 22. Now, if t3 must be 22, then by symmetry, t1 must also be 22. We have 3 of the terms down. So let's just write them out first. We have 55 plus t4 plus t5 is equal to 5y plus 1. But we must have the orderings in place for us to determine what the next possible numbers are, right? And this is t4 and this is t5. Now, what can t4 be? Well, t4, right? Well, by the same logic, right? 22 must equal to half of t4, or 22 is equal to twice of t4. So t4 can either equal 44, or t4 can either equal 11. Let's say it's equal to 11, and we'll consider the next case of 44 next. If this is 11, then by symmetry, right, this has to be 22, right? And let's see if this possible arrangement works. Well, we have 55 plus 33, right? We have 55 plus 33, which is equal to 88. Right, let me just check my work. 22, yep, 88. So 88, do we have a term, 88, that can equal 5y plus 1? Well, 5y must equal 87, and therefore y is 87 divided by 5. Y must be a whole number, so therefore this is a fraction. Therefore, when t4 is equal to 11, it will not work. In other words, t4, right, must be 44. It must be 44 something height tall. So what can t5 be then? Well, we can just use another possibility tree, right? If t4 has to be 44, then 44 must be equal to half times t5, or 44 is equal to twice times t5. So t5 can either equal 22, or it can equal 88. So it can either equal 22 or 88. Let's see which one works. If we have 22 plus 11 plus 22 plus 44, what do we get? We get 99, right? Let me scroll down a little bit more. We have 99. So it's 99 plus t5 is equal to 5y plus 1, whatever y might be. t5 can either equal 22 or 88. So let's try t6 is equal to 22. If that's 22, then 99 plus 22 is equal to 121. 121 is equal to 5y plus 1. Then that means 5y is 120. Y is equal to 24. Wait a minute, that would work. Because then we have 24.2 to be the average, right? Because remember, we supposed y, this is 0.2. So we supposed y to be this number, 0.2. So y must be 24. But let's try the other case, where t5 is equal to 88. 99 plus 88, right, gives you 187. Obviously, 187 won't work, because 5 times any number, right, must always end in either 0 or 1. If we add 1 to it, then the number must end in 1 or 2. This ends in 7. So obviously, when t is equal to 88, that would not work. t5 must be 22 inches tall. Therefore, we must have y to be 24. Therefore, your answer choice must be answer choice B with 24.2. Remember, this is y.